Okay, so just to see how those wires are connected to the ampemetric sensor, we'll loosen our strain relief here. To open the sensor and expose the terminals, it's 1/4 of a turn. Pull that up. So we have the white or clear wire connected to terminal 1, which is coming from terminal strip X2 number 9, and the black wire, which is connected to terminal 2, which is coming from terminal strip X2 number 10. This section is to show removing the sensor from the sample line and filling the membrane cap with electrolyte. So we're going to be sure that we don't have flow in our sample line. Loosen the compression fitting holding the sensor in place. Remove the sensor from its sample cell. Remove the membrane cap. I'm just going to place that there for the time being. Now this particular sensor has a very water-like electrolyte. We're going to fill that cap full. Be sure that there are no air bubbles down where the membrane is inside of the cap. Thread that cap back onto the sensor. Place the sensor back into its sample cell and tighten our compression fitting back in place. We can now start flow in the sample line. After we've changed the electrolyte, or if we first installed the electrolyte, it takes several hours to get a true reading before we want to do our calibration. Some of our sensors have electrolyte that is a bit more viscous, so to change or to add the electrolyte in that, again, we're going to remove that cap. We're going to fill that cap with electrolyte. Here you can see how much thicker the electrolyte is. We want to fill it again so there's no air bubbles. If there is an air bubble, that air bubble will migrate towards the top in time. We'll let that come to the top. Never put a screwdriver or any other instrument into the electrolyte. If you want to try to help remove the air bubble, use the sensor tip itself. We'll now thread that sensor back on. You'll see that the electrolyte will come out. Then we will want to wipe that electrolyte. Never wipe across the membrane itself. Now we can put this sensor into flow. It tends that the thicker electrolytes take a little bit longer to energize, so you'll have to wait a little bit longer to do your calibration. This section of the video will go over some of the programming of the D1C controller. Here we're programming first to match the sensor range to the sensor that we will be using in our process. So to get to the screen to change that so that it matches, we want to hit the change key, which is the top left-hand button, until we see general settings information. Now we hit the enter key to scroll into that menu until you see the word either reduced or complete flashing. Once that flashes, we can change with either the up or down button. Anything that's flashing changes with one of those two buttons. So we get to complete, we press the enter button to accept it. See that it goes back to your main display. Now we'll hit the change key until we see measuring range setting. Once we're at measuring range setting, to enter that menu, we press the enter button. You'll see that it's flashing the default range of the D1C, which is 0 to 2 ppm. We can change that again, whatever's flashing, with the up or down arrow button. We want to press one of those buttons until that matches what the sensor is that's hooked up to the unit. Here we have a 5 ppm sensor, or it could be a 10 ppm sensor that might be hooked to the unit. We'll leave it at 10 ppm. we'll press the enter button to accept that. Keep in mind that once you change that, one of the things that changes is the set point value. It defaults to half the range of the sensor. So since we told this unit that it's at 10 ppm here on this chlorine unit, it goes to 5 ppm as our set point. That's, in most application, is a very high amount of chlorine to go to that application. So be careful and be aware of that. The next thing we want to do is change our set point. We can do that in either the complete or reduced menu. So we can continue to press the change key until you see the control settings screen. If we want to get into that menu, we press the enter button. So we'll continue to press the enter button until we see set point. Set point here for this D1C on chlorine. Again, since we changed the measuring range to say it was a 10 parts per million, the default is going to go to 5 parts per million, which is half the measuring range in that case. So I can increase or decrease that with the up or down arrow button. Very common, might be 1 part per million. We're just going to set it to say 1.2 ppm. You hit the enter button. The next screen is the PID settings. We'll have another video in the future to discuss the PID settings. We're going to skip that menu for now, so we hit the enter until we get to feed forward control, which would be the next menu that's coming up. We're not using feed forward here. We want to hit the change key until, and I pass the menu, until we get to general settings, information, hit the enter button until we get to complete should be flashing. We're going to change that back to reduced because the next thing we want to do is calibrate. Calibrating the unit is telling the D1C how much residual is actually in your process water. Now before you do your calibration, be sure that flow is going past the sensor. The sensor, the D1C unit, is wired to the sensor. Power is on, and we do actually have a residual in the water until that sensor has stabilized. The reading isn't jumping up or down any longer. Once it's stabilized, we can do our calibration. To do the calibration, we're going to hit the change key, which is the top left-hand button, until we see the calibration CL screen. This is in the reduced menu, how it appears. Once we hit the enter button, you'll see the value is actually flashing. If we're in the complete menu, the verbiage DPD value is what will be flashing. We don't want to calibrate in that menu. We risk changing our 0 point at that place, and we don't want to change that 0 point. The next thing is, it's very important that once we enter to this point where this value starts to flash, we should take our grab sample from our sample line, because this value is actually representing what's in the sample at that point in time. So to know, to find out what that value is, we're either going to have to do a DPD type test or a titration, which can take several minutes, and now that number will not represent what we're doing with our grab sample any longer. So it's important to grab that sample as close to the point in time as we go into this menu as possible. Once we do our calibration and we get the value from our measurement, we can hit the up or down arrow button again to dial in to what it should be according to that measuring device or that measuring process. If it's DPD type, we hit the enter button and it's going to come back. It's going to tell us what the slope equals according to what it's measuring and what we tell it that that measurement is equal to. That slope will then be applied to that measurement and display whatever the result is. That slope is a calculated value. You cannot change it physically. It's a calculated number based off of what it's measuring and what you tell it's equal to with your calibration. So that starting slope value, here we're at 1.2. It's actually 1.20 for a 10 part per million sensor is the starting slope value. It will accept the calibration until we get to 25% of that calculated slope, or in this case, it would be 0.30 milliamps per part per million. It will accept that calibration. If we go any further and the resulting slope would be 0.29 or below, and this is on a 10 parts per million sensor, the slope, the calibration will not be accepted. It will say slope is too low and calibration is denied. In that case, most commonly, you have to change your membrane cap and electrolyte again and allow it time to energize that electrolyte. But here we have a good slope, so we can hit the enter button and you'll see we go back to the main display. Those are the basics for setting up the programming on your D1CA. It's very similar, although we're displaying a chlorine unit here. It's very similar for the other parameters that are available on ampemetric sensors as well.